In this episode, we start with certificates and certificate authorities, which are two of the main pieces that make digital trust work in everyday security. When you visit a secure website, connect to a company service, install signed software, or use a system that proves its identity, certificates may be working quietly in the background. A certificate helps answer a very practical question. How do you know that this public key belongs to the identity you think it belongs to? Public key infrastructure, PKI, depends on that connection. A public key by itself can be shared, but without a trusted way to connect it to a real identity, you do not know whether you are trusting the right party. Certificates help make that connection visible, verifiable, and time-limited. Certificate authorities help decide whether that connection should be trusted. Before we continue, a quick note. This audio course is part of our companion study series. The first book is a detailed study guide that explains the exam and helps you prepare for it with confidence. The second is a Kindle-only ebook with 1,000 flashcards you can use on your mobile device or Kindle for quick review. You can find both at CyberAuthor.me in the Bare Metal Study Guide series. A certificate is a digital document that connects an identity to a public key. That identity might be a website name, a person, a device, an application, or a service. The certificate normally includes the public key, the name or identity it belongs to, the organization or authority that issued it, the period when it is valid, and information about what the certificate can be used for. The certificate does not hide data by itself. It supports trust so other security processes can happen safely. When your browser checks a website certificate, it is trying to confirm that the public key being presented really belongs to the site you intended to reach. If that connection is trusted, the secure communication process can continue. If the connection is not trusted, you may see a warning because the system cannot confirm the identity. A certificate authority, CA, is an organization or service that issues certificates and helps others trust them. You can think of a CA as a trusted issuer. It verifies, at some level, that the requester is allowed to receive a certificate for a particular identity. Then it signs the certificate so other systems can validate it. The word signs matters because the CA uses its own trusted signing process to create proof that the certificate was issued by that authority and has not been changed. Your browser, operating system, or application already has a set of trusted roots. If a certificate chains back to one of those trusted roots, and the certificate is valid for the site or service being used, your system has a reason to trust the connection. That trust is checked, not guessed. Third-party certificates are certificates issued by a trusted outside CA. These are common for public websites because many different users, browsers, and devices need to trust the certificate without the organization manually configuring trust on each one. If you run a public website, you want visitors' browsers to recognize the certificate as trusted automatically. A well-known third-party CA helps make that possible because major browsers and operating systems already trust the CA's root certificates. This does not mean every certificate from a third party should be accepted blindly. The certificate still has to be valid, match the correct name, be within its valid time period, and chain properly to a trusted root. The third-party CA provides a trust path that many systems already understand. Self-signed certificates work differently. A self-signed certificate is signed by the same identity that created it, rather than by a trusted third-party CA. That does not automatically make it malicious or useless. Self-signed certificates can be useful in labs, internal testing, development environments, or private systems where the organization controls both sides of the trust decision. The problem is that a normal browser or device usually has no reason to trust a self-signed certificate unless that trust has been added deliberately. If a public website uses a self-signed certificate, visitors may see a warning because their systems cannot validate the certificate through a known trusted authority. For exam thinking, the difference is not that third-party always means secure and self-signed always means bad. The difference is how trust is established and who already trusts the issuer. Root trust is the foundation of certificate validation. A root certificate belongs to a highly trusted authority and sits at the top of a trust chain. Your device or browser comes with a trust store, which is a collection of root certificates that the system is willing to trust. When a website or service presents a certificate, your system does not usually trust that certificate alone. It checks whether the certificate was issued by another certificate, which may have been issued by another, until the chain reaches a trusted root. If the chain is valid, the certificate can be accepted for its intended purpose. If the chain cannot be built to a trusted root, trust may fail. This is why root certificates are so sensitive. If a root is trusted, certificates under that root can carry broad trust. Between a root certificate and an end certificate, you may see intermediate certificates. An intermediate certificate helps create a chain between the trusted root and the certificate used by the website or service. This design protects the root because the root can be kept more carefully guarded while intermediates handle day-to-day issuing. If an intermediate has a problem, it can often be replaced or revoked without exposing the root itself. When a server sends its certificate, it may also need to provide the intermediate certificates required to complete the chain. If those intermediate certificates are missing or incorrect, a user might see a certificate warning even if the end certificate itself looks correct. Certificate trust depends on the whole chain, not only the final certificate presented by the server. A certificate proves several things only when validation succeeds. It can help prove that a public key is tied to a specific identity. It can help prove that a trusted issuer signed that connection. It can help prove that the certificate is still within its valid dates. It can help prove that the certificate has not been altered since it was signed. But you should be careful with the word proves. A certificate does not prove that a website is honest, that a business is safe, or that you should trust every action taken through that site. It proves a narrower security claim. It tells your system that the identity, public key, issuer, validity period, and trust path appear to match the rules. That is powerful, but it is not the same as a guarantee of good behavior. Names matter a lot in certificates. If you visit a website, the certificate should match the name you intended to reach. If the certificate is issued for one name but presented for another, your browser should treat that as a problem. This protects you from being sent to the wrong place or from a system presenting a certificate that does not belong to the requested identity. In modern certificates, names are usually listed in a field that identifies the valid names for that certificate. You do not need to memorize field details here, but you do need to understand the concept. A valid certificate for one site should not automatically be accepted for a different site. Identity matching is part of trust. Without it, an attacker could try to reuse a certificate in a misleading way. Certificates also have expiration dates because trust should not last forever without review. A certificate is valid only for a certain period. When that period ends, the certificate expires, and systems should no longer trust it for normal use. Expiration helps limit long-term risk. If a certificate or key is forgotten, outdated, or based on older practices, the expiration date forces replacement. Expired certificates can cause real outages because secure connections may fail when systems refuse to trust them. This is one reason certificate management matters operationally. An organization needs to know what certificates it has, where they are installed, when they expire, who owns them, and how they will be renewed. A certificate can be technically strong and still create a problem if nobody tracks its life cycle. Common certificate use cases show why this topic matters so much. Website certificates help support secure browser connections and server identity. Device certificates can help prove that a device is trusted before it connects to a network or service. User certificates can support secure email, authentication, or digital signing. Code signing certificates can help show that software came from an expected publisher and has not been modified since signing. Service certificates can help applications prove identity to each other. These use cases all connect back to the same basic idea. A certificate binds an identity to a public key in a way other systems can validate. The specific use may change, but the trust function stays familiar. You are checking whether this key really belongs to the identity claiming it. Transport Layer Security, TLS, is one of the places where certificates are most visible, even if you do not usually notice them. TLS helps secure communication between a client and a server, such as a browser and a website. The certificate helps the client verify the server's identity before the secure session is fully trusted. If the certificate is valid, matches the requested name, chains to a trusted root, and has not expired or been revoked, the connection can proceed more safely. If something is wrong, the browser may warn you. That warning is not just a nuisance. It means one or more parts of the trust check did not work. You should treat certificate warnings carefully because they may indicate misconfiguration, expiration, interception, or impersonation. Certificate problems can happen for several reasons. A certificate may expire because nobody renewed it in time. It may be issued for the wrong name. It may be installed without the needed intermediate certificate. It may be self-signed when users expect public trust. It may be revoked because the private key was compromised or the certificate should no longer be trusted. The private key associated with the certificate may be stored poorly, copied too widely, or exposed. Any of these issues can weaken trust or disrupt service. This is why certificate management is both a security topic and an operations topic. The certificate is not just a file installed once and forgotten. It is part of a living trust system that needs ownership, monitoring, renewal, and response when something changes. You should also connect certificates back to private key protection. The certificate contains the public key and identity information, but the matching private key is what must be guarded. If an attacker steals the private key for a website certificate, the attacker may be able to impersonate that site in certain situations or decrypt certain kinds of traffic depending on how the key is used. If a code-signing private key is stolen, an attacker may be able to sign malicious software so it appears to come from a trusted source. That is why private keys should be protected with strong access control, secure storage, limited permissions, and careful handling. Certificate trust depends on two things working together. Others must trust the issued certificate, and the owner must protect the private key behind it. The conclusion is that certificates and certificate authorities give PKI a practical way to create digital trust. A certificate connects a public key to an identity. A CA issues and signs certificates so other systems can validate that connection through a trust chain. Third-party certificates are useful when many outside systems need to trust the certificate automatically. Self-signed certificates can be useful in controlled situations, but usually require trust to be configured directly. Root trust, intermediate certificates, expiration dates, name matching, and private key protection all affect whether a certificate should be accepted. As you study this topic, keep the purpose clear. A certificate helps your system decide whether the identity and public key belong together. A certificate authority helps your system decide whether that claim should be trusted.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.